Welcome to the IJIS Institute Sounds of Safety podcast, where our community will be delving into a series of critical issues supporting the public sector mission space. For this episode, we continue the exploration of emerging and disruptive technologies in justice and public safety. We're pleased to welcome back Larry Zorio, chair of the Cybersecurity Working Group, and Paul Wormeli, who leads efforts with the IJIS Technology and Architecture Committee. Today, Larry and Paul will dig into the transformative impact of cloud-native technologies and what that means for justice and public safety operations. From scalable infrastructure to real-time data sharing, they'll discuss how these modern platforms can help agencies become more agile, secure, and responsive. Let's dive in and hear from Larry and Paul as they shed light on how cloud-native technologies can unlock new possibilities for justice and public safety.
Hello, everybody, and welcome to another episode of IJIS Sounds of Safety podcast. I'm Larry Zorio. With me, I have Paul Wormeli. And today, we're going to be talking about cloud, specifically cloud native. And what is cloud native? Why is it important? I'm sure many of the audience members are kind of hearing, or listeners are hearing, cloud native being thrown around in different advertisements over LinkedIn, over the web, even when vendors are coming in. So Paul thought it would be a good idea to just explain to the audience what cloud native is. And we're going to be going over some of the other forms of cloud. We're going to be talking about just the benefits. We're going to be talking about security with the cloud, some trends we're seeing. And we're just going to get right into it. So without further ado, Paul, welcome to the show.
Thank you, Larry. I'm happy to be here.
Yeah, well, I'm happy to have you. It's good that we're able to get back together and talk about this important topic because I truly, firmly believe that this is absolutely a trend. We're now in 2025, and I know adoption was slow with cloud, but I believe that decision makers, technologists who maybe have been reluctant to go to the cloud are now realizing the benefits of it. And we're going to get into those benefits today. So this is going to be a really good episode. But Paul, I want you to kick it off. I'd like you to start off by just telling the audience, like, what is cloud native? And then we'll just have some back and forth and I'll add some color as well.
That sounds great. I think maybe the intro, though, should include the fact about why do you care what this is? You know, all of us that have worked in the justice field for years are concerned about how the software is built and what kind of environment it can run in. And if you're writing an RFP, what do you ask for? If you're looking for modern software that's going to be sustainable and is going to last you more than a year or two, you know, you're concerned about how's it built. So that's kind of what Larry and I are trying to focus on today is how does this help you? How does your understanding of cloud native help you with achieving your mission? So first of all, what is this stuff? Well, I have to say that you have to understand a little bit that the whole world of software development has been on an evolutionary path for 50 years. When we first started writing programs to do things on the computer many years ago, we wrote programs where all of the instructions to the computer were in one big program. And as we built more and more programs and more functional capabilities, these programs got to be huge. Some of these programs had 1 million lines of code. So what happened with that is that when something broke somewhere in all those 1 million lines of code, it infected other problems without that same program. And the whole system went to hell in a handbasket, to put it crudely. The programmer was spending all night and into the morning trying to figure out where was this problem in all those 1 million lines of code and how could we fix it. So we kind of got smart about that and said, well, you know, maybe we ought to have subroutines that would break the program up a little bit, but that still left it all in one big pile of code.
Yep.
And that it didn't solve the problem. Then eventually, about 10 or 15 years ago, we really got smart and said, you know what, maybe we ought to break the program up into pieces. And we came up with this notion of service-oriented architecture, which caught on really fast with people saying, why don't we define these applications and any application as a series of smaller chunks, smaller pieces that can be self-contained and work on their own and these services would tie together well. I kind of think about this the same way you think about an upscale restaurant you go into. What happens when you go to the restaurant? You get somebody who seats you at the table, somebody else waits on you, somebody else brings the food. These are all services that are tied together in a service-oriented architecture. Well, computer programs need to work that same way. And we also realize that all these little pieces of services, individual services, should be able to stand alone on their own, like little black boxes with an input and output, and to do small functions. That way, if one of them breaks somewhere, you know right where it is and you can go fix it. Or if it fails because of a power spike or something, you can restart it. And this made it possible to do what people call loosely coupled software, little pieces. So what cloud native is, this is kind of the epitome of the evolution of software development, in my opinion. This is really what we've come to. With the introduction of cloud computing, we said, we can put a lot of these things more into the real-time world and make them available continuously. And if we break them into pieces, those pieces can run anywhere in the cloud. They can run in Africa if you need to. But we realized we could do this, break these into little pieces. So cloud native computing really consists of three things that make this what we would call the cloud native world. It starts with microservices. That's really taking individual functions, small pieces of functions. You can think about this, for example, like a query of a fingerprint. There's a small piece of code that you can use. It happens to be a standardized piece of code, and add that to your library, call that function, and it makes a query to the state and gets a fingerprint response back, and you take that response then and feed it to another function, which is to present it to the user. So those microservices are standards for how you build those things if you want to really do this in the cloud and make it run anywhere in any cloud or even on your on-premise system or in any cloud. We have to put those little services in what are called containers. And there's software available to do that. That's open source software that any company or individual can use those open source pieces as building blocks to build that, to put those in a container. There's a program called Docker, for example, that's used frequently to build those containers. So every one of those little services is put in a container where all you care about is what goes into it and what comes out of it. What's on it, what goes on inside, it carries out that function. So if you want to change it and improve it, you can do that without affecting your total system architecture, which is really the key advantage of all of this. And then, of course, if you have all these little pieces of code and little services that have to be put together, you need somehow to have what's called an orchestration. There's, again, open source software. There's a program called Kubernetes, which is an open source software package originally developed by Google many years ago. This is the basis for how Google built its empire, this orchestration package. A lot of these open source tools are actually maintained by a nonprofit organization that manages all these various cloud functions. Anybody can use them, and they're readily available and open source. So Kubernetes is the most common orchestration package that people use to connect all these little pieces of code and little services and make them loosely coupled. Kubernetes is extremely powerful because it really lets you manage how these services are called and used and applied to do a function, and also monitors them. So if something breaks or something happens to one particular service, Kubernetes can restart that service and manage it so that you get resilience out of this that you never got with those old programs that were all one big pile of code. When they broke, they broke. But what Kubernetes does with its orchestration skills, it's like the conductor of an orchestra. Kubernetes calls upon the violins to tone down their volume so you can hear the oboe and pull all the pieces together to write a symphony. In the end, you're writing a symphony with the contributions of the oboes and the violins and the violas and the timpani, and Kubernetes is the conductor that ties all those pieces together and tells them when to play or shut up. So that's
great.
kind of the model that you have to think about this stuff. And the beauty of all this is that, like I said, it runs on any cloud platform, whether it's Microsoft or Google or IBM or
AWS.
eBay or
Yeah.
whatever.
Yep.
And the other thing is what makes this really cool is that you can run that on your own laptop. You can run it on a server in your department. You don't have to go to the cloud to do this because all these open source, these basic tools that are in the cloud native environment are extremely portable over operating systems and environments so that you can really put them anywhere. And you can put these pieces anywhere and tie them all together. And by the way, you can do that essentially in real time. Because what happens when you build this and according to the specifications is that you specify a place where they run that they're called to do their job.
Paul, you brought up a couple good points there. As you were explaining, I'm pretending I'm the audience and I'm listening to you explain this. And it's like the analogies are great. I love the restaurant analogy. That was wonderful. The symphony is another good one. And it's like, so what? So for someone who's not a technologist and they're listening to you explain this, it's so what? And you hit on a couple points that I want to bring up again. The clusters, the microservices, listeners, this all sounds techie, but Paul had mentioned like building blocks. Think of an application or some software that you're using. If it's on-prem, it's just one big piece of software. It's just one big block. And if that software or that block gets sick, you can't use the software. You just can't. It won't work. Or you have to get tons of people working on it, reprogramming it, patching it, taking it down. It's down for a couple days, bringing it back up. Versus what Paul was saying around these building blocks. Think of a modern cloud native software or architecture as being a bunch of Lego blocks. And if one of those Lego blocks gets sick, you can remove it and the software keeps working. And you can remove it automatically with Kubernetes, which Paul was talking about, to work on it and fix it. And that can be all done automated. Or if a programmer or human needs to get involved, they can remove it. And it all happens in the background while your resilient system is still up and running. So that's an important one. I do think it's important to explain the differences because the audience may be saying, oh, well, I have cloud native. We're in the cloud. I have cloud native. But there are many different types of cloud. And I do want to kind of go over probably just like 4 different examples of cloud. So I'm going to try to go in order here. The first one I want to talk about is private clouds, which are really like a dedicated single tenant that your organization controls. You can either host it yourself in your own big data center, or maybe you have an off-site, an off-premise data center, or you can use a third-party facility, but it's something that you completely manage yourself, which means you're doing all the care and feeding. You don't really get to take advantage of some of those microservices and automations that Paul was talking about. Then you have public clouds. So these are managed completely by a third party, right? Like Paul mentioned some of them, like some of the big ones, like Google, AWS, Azure, IBM. You are paying them to get access to all of their resources. You're paying them to get access to some of the operations that they do for you, like the care and feeding. You're also paying for their horsepower. I will like pretty much guarantee this for this audience. They are going to have a faster, stronger, more reliable server than you are. They just are because they have deep pockets. They absolutely are going to. So you could take advantage of that in a public cloud, one of these third parties. All right, so I mentioned private and public. The third option I want to bring up is a hybrid cloud. So a hybrid cloud is you have some of your infrastructure, some of your systems on premise, and you have some in the cloud. And they kind of work together and, they try to share data, but there are some hiccups with that because some of the integrations don't work correctly. You still can't completely take advantage of the automation that Paul talked about. You can't take advantage of those microservices where if one block gets sick, you can very easily take it out while everything stays up and running. Then you get to the final one, which was what Paul was explaining, which is cloud native. The very simplest version that I can bring up for the audience around cloud native would be if you use Office 365. If you use email in the cloud, that is cloud native. You're accessing email in the cloud. Microsoft's taking care of it for you. If it gets sick, they can fix some things. You can make some changes on your own, but you're not doing that on a physical server in a closet or in a basement. You're doing that up in the cloud. And as soon as you make the change, it can happen behind the scenes. Your users aren't impacted when you make that change. You don't have to bring your whole email server down. You can just make the update. So that's a really good example. There are, especially in public safety, there are RMS and CAD systems. There are license plate readers in the cloud. There are 911 dispatch systems in the cloud. There are really like a lot of options you have if you're open to it. And, I said it at the beginning of the show that I do think that technologists in this space are starting more and more to open their eyes to these different options. Paul, with the 4 examples that I gave, is there anything you wanted to add? And it could be either details on them or even just benefits on either of those 4.
Yeah, I'm glad you laid it out like that, because all of those options are important. But I think the notion of cloud native is that if you build an application, when you acquire an application that is truly cloud native, in that it uses microservices, containerization, and orchestration, and those things we talked about, it'll run in any of those environments, on-premise, private cloud, public cloud, and using things like the open source tools that are available to any developer makes it so powerful, because they've built these tools so they'll run on top of Windows, on top of Mac OS, and Linux. And there are companies, of course, that have built packages of all these public open source products that take advantage of it. That's what the whole Microsoft Azure environment is about, or the Google Cloud GCP program that pulls all this stuff together. And it gives you that ability then to be indifferent about where you put this, whether you decide for other reasons, like control over the programs or your concerns about privacy or whatever, to decide whether you want to keep them in premise or put them in even a public cloud. What I think Larry talked to you about, though, is the approach that I see most agencies leaning towards, and that's the hybrid cloud, but having cloud native applications running on a hybrid cloud. So some of the components, some of these microservices can reside on your own premises. Things like identifying the users and controlling cybersecurity issues, and can be handled with the user interface that's running on your own premises, but reaching out to the cloud to run other applications like a fingerprint search, for example. And you can put them anywhere. What has happened is that the companies that package all these pieces together have learned that it's important in the government world to make sure that you have, for example, that these services run perhaps in your own state, or at least in the U.S., as opposed to running in Russia, for example, or China. So they've built government cloud programs that are certified and qualified and meet privacy and security requirements of NIST and the federal government and state governments to control where these services work, which gives you a lot more confidence that you're in command of what's going on here, and it's not these big tech companies that's taken away your software, your access. But the benefits are resilience, not having software breakdown like it used to frequently. We've all been through that in our past, but being able to keep the system going, even if one piece is faulty for a time, it can be restarted, as I mentioned earlier and Larry talked about, or make sure that the overall system is still running. So we used to deal with that when I was involved in building CAD systems, and Larry has been, that you had tons of redundancy. Everything had to be redundant. But even with that redundancy, there were times when the system would go down and then you had to go through several hours of restart. Sure. That's no longer necessary. You're up all the time. And there's an element of real time about all of this cloud native stuff that you've never got before. A lot of the updates to files and stuff that the old major big software piles of code did, you ended up having to restructure your database nightly or issue batch updates nightly before you could update things. Well, because of the loosely coupled nature of cloud native computing and the microservices, you can update stuff all the time in real time. You don't have to wait for a nightly batch update. And that's been an important step forward in public safety in particular, because you really need access to the latest information at any time that you're using this information to make decisions. So having that real-time capability and the connection of all these microservices, no matter where they are, but available constantly to improve what you're doing, just enormously improves it. It also, in the end, cuts your costs, because when you're really taking advantage of cloud native applications in a cloud environment, you have that potential of only buying those services that you need at the time you need them. So you can scale up if you have an emergency, but you can scale back. A lot of governments are still struggling with how to handle that, because particularly state and local governments are used to having an annual budget and that's all you have to spend. But with the advent of cloud native solutions and cloud computing, you can actually only buy those computing services that you need at the time you need them. And that could result in significant savings for lots and lots of agencies.
Hey, Paul, can we stay on this for a bit? Because I've heard a lot of challenges around cost. Let's play devil's advocate here, okay? I'm going to be someone who's reluctant to go to the cloud. Paul, there's no way that it's cheaper to go to the cloud. I have all these servers in my data center that I can run this software on that I invested in 10 years ago. There's no way it's cheaper.
Yeah, well, that's a general fallacy when you make that claim, because you're not thinking about the total cost of ownership. Mm-hmm. If you think about all those servers you have in your back room, who runs those servers? You're going to have a system manager. You're going to have technicians that have to watch and do the monthly updates and patches to every operating system that Microsoft or whoever comes out with. You're going to have to buy and pay for those servers and the updates to those servers. And we all know that the general logic in the computing industry is that computers wear out in 3 to 4 years. It's not because they're all that broken, although sometimes they are, but new features come out and software operating systems get updated and your old system is no longer being supported. Many, many public safety agencies have run into this huge problem of the cost keeps going up for maintenance the older the system gets. And pretty soon the cost of maintenance exceeds that of the cost of a new system. And with this kind of architecture of cloud computing, you don't care about that. You don't have to hire anybody. You don't have to have a staff. So if you think about writing off the cost of those servers you're talking about, and the cost of operating them, and the cost of updating them, and the cost of all the staff it takes to keep them alive and well, your total cost is going to be less, particularly if you take advantage of the flexible payment capabilities in the cloud. If you don't have a whole lot of crime in one particular month, and you don't have a lot of inquiries, and there's not a lot going on, particularly in a smaller community, you could cut your costs radically. If you have it all on premise, you're stuck with that cost no matter what the load is. Mm-hmm. And guess what? When you have a major fire, like we just saw in California, you need a whole lot more services that aren't available to you because you're stuck with the system you bought, and you're not going to go out and buy a whole new system and just because there's a fire in your neighborhood.
Yeah.
But with cloud computing, you can extend those resources as far as you want, just instantaneously. So with the flexibility to respond to public safety issues is a major, major issue on this. Also, I'll give you one really clear example of this. After Katrina, I was asked by the Chief Justice in Louisiana to go down there and try to help them figure out how to restore the operation of the justice information systems. And it was really interesting to discover that none of those parishes, except one in Louisiana, had off-site backup plans.
Oh, boy. Only
none of
one?
them.
Oh.
Only one of the 9 major parishes that were most impacted. So what happened is that they had to release 4,500 people from jails and prisons because all the evidence got destroyed in the flood.
What?
They had to.
I didn't know that. Wow.
There were hundreds,
Wow.
thousands of people who lost the deeds to their houses because they were stored in the basement of the courthouse,
Oh.
and the water went up to the ceiling in the basement of the courthouse. So what cloud computing initially offered, and a lot of people have seen this light, the ability to store your data, replicate your data in an offsite cloud environment somewhere 100 miles away from you. It's a really smart move. It's that contingency of operation. If for no other reason, that's a reason to go to cloud computing.
Mm.
And by the way, the cost of doing that is a lot less than buying a complete duplicate system yourself and putting it in their basement of the courthouse where it's likely to be flooded out the next time the flood comes up.
All right, Paul, I want to talk about 2 points that you made. If I get a response on each of them, the first one's going to be a challenge again to you. All right. I am a technologist for an agency, and I just heard you say that if we move to the cloud at my agency, there's no longer going to be a need for me or my team to work on these servers or on this server room anymore. And that gives me heartburn. That gives me fear that I'm going to lose my job. What is your response to that?
Oh, you'll never, ever lose your job because the demand for more functionality is endless. And what this will do is free you up from worrying about tweaking the operating system and loading patches every month into looking at how can you satisfy the new functionality that your users are demanding. How can you make life easier for your users? How can you make the system more responsive? How can you work with the suppliers of these tools to ensure that they're working better, faster, and cheaper all the time? It elevates your job from doing these really sort of grunge work tasks of installing patches every month and doing those kinds of things, and much more interesting and challenging work that is much more satisfying because you're helping people achieve their mission. You're not just fixing broken patches and obsolete operating systems.
I actually love that perspective that you said at the beginning, that you have this new technology and your leadership and your town, everybody, they're going to want more of it. They're going to want more functionality. That's a really good way to put it. You think about any new technology that you get. For instance, a lot of us are using ChatGPT now, right? And when we first got that thing, we were amazed by it, and then we wanted more. We wanted it to do more. Can it do this? Can it do that? The example I'll give for the audience who maybe you're blessed and you actually do have some data analytics within some of your platforms that gets rolled up to your command staff or to town officials, city officials, or who knows, maybe even the state. And as soon as you turned that new data analytics functionality on, what was the next thing that you got from them? Questions about them wanting more. They want to see more. So that's a really good point.
And new technology shows up. And instead of working on patching your old Unix operating system, wouldn't you rather be looking at how can you take advantage of generative AI or new AI applications? This year, 2025, lots and lots of people are saying this is a year of agentic AI, creating agents to do work. Now, that whole field is wide open. It's an amazing potential that we look at some of the applications of not just generative AI, but other variations of AI and machine learning. And wouldn't you rather be trying to figure out how to take advantage of those new tools in AI, create users, than worrying about how to patch that old Unix operating system?
Yes, we would. That's a great question. All right, the next point I wanted to bring up that you touched on was new features. I think that's a really good point. If you're used to these monolithic kind of older systems that are on-prem, if you want new features, oh boy, if you want a new module added, if you want a new integration, like that is some serious work. And typically the vendor is going to charge you for that. When you go the cloud native route, like let's talk about just software, like you're just using software in the cloud, vendors, partners, they're turning on new features all the time. And yes, some of them they are going to charge you for, like if it's a big change, this whole brand new module. But other things, no. And the example I'll give is on the security side, because that's my expertise. CJIS requires encryption. And I know you've probably heard that before. They require different types of encryption. And one of the encryptions they require is FIPS 140-2. And that's been the standard for a while. Well, there is rumblings that eventually they're going to require a newer version. So we at Mark 43 said, what the heck? Let's just go behind the scenes and turn on 140-3. And we turned it on. And we didn't go back and charge our customers for it. So there's a lot of those little things that would be a big deal if you were using kind of the more traditional on-prem versus cloud native. These things can happen very quickly, a lot of additions and upgrades and new features. Anything more you want to add to that, Paul?
Yeah, that's a really good point, Larry. And I'll give you another example that's perhaps even more significant. Because the cloud native applications are built with these microservices, in any given microservice, I think about this with respect to CAD systems. You know that CAD systems have to operate with microsecond response times. There's no time to wait. The coding has to be very efficient. And if you have a cloud native CAD system that you've built, you can look at a particular function like how to enter a query for somebody. And if your engineers say, well, there's a faster way to do this, you can make that particular little microservice, you could update that without interrupting the service in any way, shape, or form, and have that system perform 100 times faster than it did.
That's great.
Just put that one little microservice.
Mm-hmm.
And the users don't have to put up with any downtime, like you were saying earlier, waiting 3 days to get this installed and then restarting the system and retesting everything. And it's going to be done automatically because it's being done in the cloud.
Mm-hmm.
And you don't even have to know it happened. You just all of a sudden your system is 100 times faster.
That's beautiful. Love that.
It's so important to give that freedom and flexibility of monitoring changes and making changes.
Definitely.
Just take that a little bit further. There's the whole software engineering and development process is changing because of these technologies, and particularly cloud native technologies. People have adopted, I'm sure your company is, and others are really into this, a whole approach of what's called DevOps, which is really fostering collaboration and automation between development and operations teams, of getting the users involved with the developers and taking small steps that are happening on a weekly basis to make improvements. And this whole notion of how you build software, you don't wait like we used to take 18 months to write code and then have it only to discover that the customers don't like it anymore. You make these changes, small changes all the time, and get feedback from users and make it involve the users. This is really the way software should have been built all along, but we're finally said with these tools and having microservices and these other tools, you can do that kind of thing. There's also a notion now that's really taking place of, we really talk about continuous integration, continuous delivery, which is kind of what you're talking about.
Yeah. Sorry, I got to ruin your flow for a bit. We only have 1 minute left, and I want to make sure we close this out the right way. So in 30 seconds, what advice would you give someone who's going to try to approach cloud native?
Educate yourself a little bit about what these tools, go to the Cloud Native Computing Foundation and read about Kubernetes and these other tools. Start looking at how you ask for them in an RFP. Ask your software supplier if they're capable of cloud native computing. And if not, why not? And if so, when do you get it? And start building that out and adopting this whole concept.
Great. To me, I would just lean on your vendors. Ask if they have options like this for your partners. Use your partners more and more. Okay. That ends our episode for today of the IJIS Sounds of Safety podcast. We hope you enjoyed this conversation with myself and Paul around cloud native, and stay tuned for more, people. Okay. Thanks, Paul.
Thank you, Larry.
Bye, everybody.
Thank you for tuning in to today's episode of the Sounds of Safety podcast. Be sure to stay connected with the IJIS Institute on LinkedIn and X, and don't forget to subscribe on Apple Music, Spotify, or your preferred podcast platform to catch future episodes. From cybersecurity to artificial intelligence and deep dives into critical national data sharing initiatives, the Sounds of Safety podcast has you covered. Until next time.